Hi everyone, welcome back to the channel. This is video 2 in our React interview question series. And if you have not seen the video 1 yet, get checked that first we cover 30 questions on React fundamentals, JSX components, hooks and core patterns. Today we are moving into more advanced concept state management with Redux context and just and performance optimization techniques, the basics of testing React apps, and then we will wrap up with some real situation and behavioral question you might actually get asked in the interview. So 30 more questions, so let's get straight into it. So let's understand what is state management and why does it become such a big deal in the enterprise's application. So state management is about deciding where your application data lives and how different components read and update it. In a small app, a couple of use state calls are enough, but once you have dozens of components that all need to know about the logged in user, a shopping cart, or a theme setting, passing the data around manually through props get messy. So that's the prop drilling problem we touched in the video one. So good state management give us a predictable source of truth. So any component that needs a piece of data can get it directly, and any update flows back out consistently. On screen you can see the three big reasons this matters: share data across distant components, avoid prop drilling, and predictably knowing exactly where a value comes from and what can change it. So this is exactly the problem with Redux context and just and which we are covering next. So so let's move to slide 3. What is the context API and when should we use it for a state management? So we touched on use context briefly in video 1. So let's go on a deeper level. When should you actually reach for the context API as your state management solution? Context is built directly into React, so there is no extra library to install. You wrap part of your three in the provider, hand it a value, and an descendant component can read that value with use context. No manual prop passing required. On screen our theme context is set up with the provider in app and toolbar, read it directly. So context works really well for data that doesn't change often. Theme, locale, the current authenticated user, where it starts to struggle is high frequency updates. Every component consuming a context re-renders whenever that context value changes, and there is no built-in way to describe so, so for a something like for a state that updates on every keystroke or a large frequently changing store, context alone usually isn't the right tool. So that's where Redux or Just Stand tend to take over, which we are going to cover in next few slides. So let's talk about Redux, a name that comes up constantly in React interviews. Redux is a predictable state container for a JavaScript apps. It is not actually tied to React specifically, but it's the most commonly used alongside it. It's built on three core principles, and interviewers love asking for these by name. So first single source of truth, your entire application state lives in a one JavaScript object inside one store. Second, state is read only. You can never mutate it directly. The only way to change it is by dispatching an action, a plain object describing what happened. And the third, changes are made with pure function. Reducers take the previous state and an action and returns a brand new state object without uh, mutating the object. So why does this matter? Because the predictably makes state changes traceable and debuggable. You can literally log every action and see exactly how your state evolved over time. So that's the foundation. Everything else in Redux builds on. So let's look at action, reducers, and the store in more detail next. So the question, what are the actions, reducers, and the stored in Redux? So in every state management interview, you will get this question. So let's break down the three building blocks of Redux that we just introduced: actions, reducers, and a store. An action is a plain JavaScript object that describes what happened. It always has a type field and optionally a payload with the extra data on screen. Our increment action just says counter slash increment, nothing more. A reducer is a pure function that takes the current state and an action and decide what the new state should look like. Our counter reducer checks the action type, and if it matches increment, returns a new object with the value incremented. Otherwise, it just returns the state unchanged, and the store ties it all together. It holds the state and exposes dispatch, which is how you trigger a state change by sending an action through the reducer. You can see we create the store with create store, passing in our reducer, and then dispatch the increment action to update it. In an interview, being able to trace this flow, action goes in, reducer computes the new state, store updates, is exactly what shows you actually understand Redux, not just that you have used it. So next question, what is a Redux toolkit and why is it preferred over legacy Redux? So, if you have heard people say nobody writes Redux the old way anymore, this is what they mean: Redux Toolkit, or RTK in small. So legacy Redux involves a lot of boilerplate. You handwrite action types, action creators, and switch statement reducers, and you have to be really careful never to mutate state directly. Redux toolkit was built by the Redux team themselves to cut all of the down. The star of the RTK is create slice. You give it a name, an initial state, and a set of reducer functions, and it automatically generates the action types and an action creators for you. And here's the part people find surprising: inside those reducers, you can write code that look like it's a mutating state directly, like state.value plus plus. Under the hood, RTK uses a library called immer, which safety converts that into proper immutable updates. On screen, you can see the comparison. Largely, Redux needs manual action types, handwritten reducers, and carefully immutability. RTK collapses all of that into one. So create slice call with the store setup pre-configured to for any new Redux project today. RTK is the standard recommended approach. So what is a middleware in Redux, and what does Redux thunk do? So Redux on its own only handle synchronous plain object actions. So how do you handle something like an API call? So that's where middleware comes in, and especially Redux thunk. Middleware sits between dispatching an action and it reaches the reducer, letting you intercept, delay, or modify that action. Redux Thunk is the most common middleware for handling asynchronous logic. It lets an action creator return a function instead of a plain object, and that function receives dispatch as an argument on screen. Fetch user returns an async function. Inside it, we first dispatch a loading action, then await the fetch call, and once we have the data, dispatch a loaded action with that data as the payload. Without thunk, you simply can't dispatch a function like this. Redux would throw an error because it expects a plain object. The key interview point here: Thunk gives you full control over dispatching multiple actions at different points in an async flow, which is exactly what you need for loading states, success states, and error states around an API call. Next, so what is a Redux Saga and how is different from Redux Thunk? We just covered Redux Thunk. Now let's compare it to the other major async middleware you will hear about in interviews, Redux Saga. Where Thunk uses plain function and async await, Saga uses generator functions and something called effects. Special instructions like call, put, and take every that describes what should happen without actually performing the side effect themselves. That's a very different mental model and it comes with a real learning curve. So why would anyone choose the more complex option? Saga really shines with the complex async flows. Think like canceling an in-flight request when the user navigates away, debouncing a search input, or coordinating multiple actions that depend on each other. Because Saga describes effects rather than run them directly, they are also much easier to test in isolation and easier to cancel cleanly. On screen, you can see the traits of laid out thunk for a straightforward API call, where simplicity wins, and Saga when your async logic gets genuinely complex and you need that extra control. In an interview, showing when to reach for the heavier tool is much more valuable than just knowing the syntax. So, what is Just and how does it compare to the Redux? So Just is a small, unoptioned state management library where Redux needs a provider wrapping your app, action types, and often a fair bit of setup. Even with the Redux Toolkit, Just gives you a store as a plain hook, no provider required at all. On screen, create takes a function that returns your state and a function that updated here count and an increment function using set. This then in any component you just call use store like a regular hook and pull out exactly the pieces you need. The big appeal is how little boilerplate there is, no action, no reducers, no middleware required for the basics, and component only re-renders when the specific piece of state they read actually changes. That said, Redux still has a strong ecosystem for a very large team, dev tools, strict conventions, and time travel debugging that some organizations rely on for small to mid-sized apps or teams that want state management without the ceremony. Just and has become a genuinely popular choice. So why would you choose context API versus Redux versus Just Stand? So that's a great synthesis question interviews love to ask. Context, Redux, or Just Stand. How you actually decide. Context API is built into React, so it's a natural first choice. So it's the best suited to data that doesn't change very often. Think theme, locale, or the current logged in user. Push it too far with high frequency updates, and you will start seeing unnecessary re-renders across your whole consuming tree. Redux is the right call when you are on a large team or building a large complex application where you genuinely need strict conventions, a mature dev tool, ecosystem, time travel debugging, and a very explicit auditable trail of every state change. Just and sits in between, minimal boilerplate, quick to learn, and a great fit for small to mid-sized apps or teams that want more structures than plain context without the ceremony Redux brings. On screen, you can see all three side by side. The honest answer for an interview: there is no universally best one. It depends on your app scale, your team size, and how often that shared state actually changes. Uh, so, what are selectors and why do they matter for performance? So this is a small concept that has a big impact on performance in Redux and similar state libraries. Its selector is just a function that extracts a specific piece of data from a store. Instead of pulling the entire state object into a component, you write a selector that returns only what that component actually needs. Why does this matter so much? So look at the top example on screen. Grabbing the entire state means the component re-renders on literally any change anywhere in the store, even completely unrelated ones. The second example, selecting just state.user means it only re-renders when that specific slice changes. For more expensive derived data like filtering a large list, you would reach for a memoir selector using a library like reselect shown at the bottom. Create selector catches its result and only recomputes when it's actually input change rather than on every single render. The interviews takeaway selectors are just a stylistic choice. They are the direct performance optimization. Narrow, well written selectors are one of the easiest wins for cutting down unnecessary re renders in a Redux app. So, what causes unnecessary re renders in React? So this is totally performance related. Starting with the classic interview question, uh, this may be the question you will be asked in every modern React interview. The first big cause is passing new object, array, or function reference as props on every render, even if the values are logically the same. JavaScript sees a new reference each time. So, memoized child component using React.memo still re-renders because from its perspective, the prop change. The second is context. When a context value changes, every single component consuming that context re-renders, even if it only cares about one small part of the value. And the third one people forget most. By default, when a parent component re-renders, all of its children re-renders too, regardless of whether their own props actually changed. Also on screen are all three. Recognizing these patterns is exactly what tools like useMemo, useCallback, and React.memo, which we covered in video one, exists to fix. So next is let's look at how we would actually go about finding these issues in a real app using the profiler. So the question becomes, how does the React Dev Tool profiler help you find performance issues? So we know what causes unnecessary re-renders, uh, but how do you actually find them in a real application? That's exactly what the React Dev Tool profiler is for. You install the React Developer Tools browser extension, open the Profiler tab, hit record, interact with your app the way a user would, and then stop recording. What you get back is a flame chart for every render that happened. Why does bars represent component that look longer to render, and you can click into any one of them. The really useful feature for debugging is the why did this render information for a given component. The profiler can show you exactly which prop, state, or context change caused that specific render to happen. That turns a vague feeling of this feels slow into a precise evidence-based diagnosis. On screen are the three steps: record, read the flame chart, and check why each render happened. In an interview, mention the profiler by name and that it tells you the specific cause of a render, shows you have actually debugged real performance problems, not just read about them. So, what is code splitting and how do you implement it? We touched on React.lazy and suspense briefly in video one. So, let's go deeper on the bigger concept behind them, code splitting. So, by default, a bundle like a Webpack or a Byte packages your entire application into one big JavaScript file. As your app grows, that file grows too, and users have to download all of it before they can interact with anything, even parts of the app they might never visit. Code splitting breaks that single bundle into smaller chunks loaded on demand. On screen, the top import brings dashboard into the main bundle immediately. The bottom version using React.lazy with a dynamic import splits it into its own separate chunk that only download when dashboard is actually rendered. So wrapped in suspense to show a fallback while that download happens. The most common real world pattern is route based splitting. Each page of your app becomes its own chunk, so a user visiting the login page never download the code for the admin dashboard. This directly shrink your initial bundle size and improve the time it takes for your app to become interactive, a metric interviewers often refer to as time to interactive. So, what is the list virtualization and when we need that? So, here's a performance question that comes up whenever an app deals with the big list. What is virtualization or widowing, and when we need that actually? So imagine rendering a list of 10,000 items without any optimization. React creates 10,000 real DOM nodes. Even though at any given moment, the user can only actually see maybe 15 or 20 of them on screen. So that's an enormous amount of wasted rendering work. Virtualization solved this by only rendering the item currently visible in the viewport plus a small buffer just outside it. As the user scrolls, it swaps which items are rendered, reusing the same DOM nodes instead of creating thousands of new ones. On screen, we are using React Window, one of the most popular library for this. Fixed size list takes the total item count, a fixed row height, and render function, and it handles all the scroll math internally. The interview signals here is knowing when to reach for this. Virtualization matters specifically for long list tables feeds. For a list of 20 or 30 items, it's unnecessary complexity we don't need. So let's move to another. What is debouncing and throttling, and how do they differ? So this one is not React specific question, but it comes up constantly in front end performance interviews. Debouncing versus throttling. So whether you are appearing for a React interview, Angular interview, Vue.js interview, this may be the question, uh, and it's an important question. So let's understand debouncing delays running a function until activity has actually stopped for a set period. Picture a search input instead of firing an API call on every single keystroke. You debounce it, so the call only fires once the user pauses typing code. So 300 milliseconds. If they keep typing, that timer keeps resetting. Throttling is different. It limits a function to running at most once per fixed interval, no matter how many times the triggering event fires. A classical example is a scroll handle. You don't want it running hundred of times a second, so you throttle it to run, say, once every 100 milliseconds, giving you a steady, predictable rate. On screen, you can see the comparison debounce for search inputs and autosave, where you only care about the final settled value, throttle for scroll and resize handlers, where you need regular updates, just not on every single event. Knowing exactly which one fits which scenario is what separates a good answer from a great one here. So let's move to next question. How do you avoid unnecessary re-renders when using context? We mentioned earlier that context is a great for high frequency updates. So let's look at the practical technique for reducing those re-renders when you uh, don't want to use that. So uh, the biggest one is splitting a single large context into several smaller focused ones. On screen, the top example bundles user, theme, and card into one app context, meaning a change to any one of those three re-renders every component consuming that context, even ones that only care about theme. The bottom example splits them into three separate providers, so a cart update only re-renders component subscribed to cart context. Two other techniques worth mentioning: a push further in an interview, memoizing the value object you passed to a provider with use memos, so you are not creating a brand new object on every parent render, and wrapping consuming components in the react.memos so they can bail out of re-rendering when their own props haven't changed. So put together, these are the standard answer to context causes too many renders. What do you do? Split the context, memorize the value, and memorize the consumers. What is React dot strict mode and what does it actually do? So quick one that trips people up. What does react.strict mode actually do, and why does my component render twice in development? Strict mode is a development only tool that helps surface potential problems early. It doesn't render any visible UI, you just wrap part of your tree in it, and react activates extra checks specifically in development mode. The most noticeable effect, and the one that confuses people the most, is that strict mode in intentionally double in inbox render function and some effects in development only. So this is deliberate. It's a design to help you catch impure code, like a component that accidentally mutates something outside itself during render, or an effect with a missing cleanup function. If your code is truly pure, running it twice produces the exact same result, so you would never even notice. Strict mode also flags legacy, unsafe lifecycle methods on class components, and warns about deprecated APIs. The key detail for an interview: none of this runs in your production build. It's purely a development safety net, and it adds zero overhead. So, what your user actual experience? So, let's move to another. What is difference between CSR, SSR, and SSG? So a topic that comes up a lot once interviews go beyond basic React into real world app architecture. So client side rendering, CSR, or what a typical create React app setup does by default. The server sends a mostly empty HTML shell. JavaScript takes over in the browser to render everything. It's a great for interactive apps and dashboard behind a login, but the user sees a blank page until that JavaScript loads and runs. So server side rendering, or SSR, renders the actual HTML on the server for every single request and sends fully formed HTML to the browser. That means the user sees real content immediately, and it's much better for SEO since search engines get real HTML to crawl, but it does add server load and response time, since that work happens on every request. Static site generation, or SSG, pre-renders your HTML page at build time before any user even requests them. Then those static files get served instantly from a CDN. It's incredibly fast, but the content is fixed until you rebuild and redeploy. So on screen, you got all three side by side. The general rule interviews look for: CSS for interactive, logged in apps; SSR for dynamic, SEO sensitive pages; and SSG for mostly static content like blogs and marketing pages. What is hydration in server? What is hydration in server render React apps? So since we just talked about server side rendering, this naturally flows. What exactly is hydration? When a page is server rendered, the browser receives real fully formed HTML. The user can see content immediately, but that HTML on is static. It's not interactive yet. None of the click handlers or state are wired up. So hydration is the process where React JavaScript runs on the client, and instead of throwing away that server render HTML and re-rendering everything from scratch, it attaches to the existing DOM nodes, wires up event listeners, and takes over reusing what's already there. On screen, the server sends a div with our heading already rendered on the client. Instead of calling the regular create route and render, we call hydrate route, pointing it at that existing DOM node. React then matches its virtual representation against what's already on the page and make it interactive without needlessly recreating those nodes. One important interview detail: if the HTML React expects doesn't match what the server actually sent, so you get a hydration mismatch warning, and React has to fall back to re-rendering that part client side, which is exactly the extra work hydration was meant to avoid. Next question: what is Next.js and why is it commonly paired with React? So Next.js comes up constantly in React interviews. So let's cover it directly. What is it, and why do so many teams reach for it instead of plain React? So React on is just a UI library. It doesn't include a router, a build system, or a way to render on the server. You have to bring those in yourself. Next.js is a framework built on top of the React that provides all of that out of the box. The biggest piece is rendering flexibility. Next.js supports server side rendering, static side generation, and incremental static regeneration, all in the same project. And you can choose per page which strategy fit best for you. It also gives you file based routing. You create a file inside the pages or app folder, and Next.js is automatically turns into a route. No manual router configuration needed. On top of that, it handles a lot of production concerns automatically: code splitting per route, image optimization, and API routes for lightweight backend endpoints, all built in. So if you are asked this question in the interview, just say React handles the UI, Next.js handles everything around it: routing, rendering, strategy, and production performance, which is exactly why it becomes the default choice for most real React application today. What is incremental static regeneration, or ISR, in Next.js? So, following on from SSG, what happens when your static content actually needs to change sometimes without a full manual rebuild? That's exactly what incremental static regeneration, or ISR, solves. We said earlier that SSG builds page once at deploy time and serves them statistically. After that, ISR keeps that same speed but adds a revalidation window. You tell Next.js how often a given page is allowed to regenerate in the background. On screen, get static props returns a revalidate value of 60 seconds. That means the page is served instantly from the static cache, just like normal SSG. But if a request comes in after 60 seconds have passed, Next.js regenerates that page in the background and swaps in the fresh version of the next visitor without anyone experiencing a slow blocking rebuild. So this gives you the best of both worlds: the speed and reliability of static pages combined with context that stays reasonably fresh without needing to triggering a full site rebuild every time something changes. It's a great answer if an interviewer asks how you handle a product page whose price or stock change occasionally but doesn't need to be real time. So let's move to question 22. What is Jest and how React testing library used for? So starting with the two tools that you will see in almost every React project, Jest and React testing library. So Jest is a JavaScript testing framework and it gives you the test runner itself, the describe and test functions, sessions like expect and built-in mocking utilities. So it's the engine that actually runs your test and report result. React testing library, often just called RTL, is built specifically for testing React components, and it's guided by one core philosophy: test your components the way a real user would interact with them, not by reaching into internal implementation details. On screen, we render our counter component, find a button the same way a user would by its role, and simulate a real click with fire event. Then we assert that the text one now appears on the screen using get by text. The interview worth in detail here. RTL deliberately avoids things like assessing component state directly or testing internal method call. If your test would break because you renamed an internal variable but the actual user facing behavior didn't change, that's usually a sign the test is checking the wrong thing. What is the difference between unit integration and end to end test? So, the fundamental question that goes beyond just React. Uh, so unit test checks one small isolated piece, a single function, a single reducer, a single component in complete isolation from the rest of the app. These are fast, cheap to write, and you typically have a lot of them. An integration test checks how several pieces work together. For example, a form component along with its validation logic and the state it updates, verifying they behave correctly as a group, not just individually. An end-to-end test or E2E test simulates a real user going through an entire flow in an actual browser, signing up, adding something to a cart, and completing checkout. For instance, tools like Cypress or Playwright are common here. These are the most realistic tests, but also the slowest and the most expensive to maintain. On screen, you can see the progression from fast and narrow on the left to slow and broad on the right. The classic advice, often visualized as the testing pyramid, is to have lot of unit tests, a moderate number of integration tests, and just a handful of critical E2E tests covering your most important user flows. How do you mock API calls in React component test? So here's a very practical testing question. Your component fetches data from an API. How do you test that without actually hitting a real network endpoint? So you mock it. The idea is to replace the real API function with a fake version that you control completely. So your test is fast, reliable, and doesn't depend on a real server being available on screen. Just don't mock replace our entire API module with an auto mocked version. Then mock resolved value tells our fetch user mock to resolve with a specific fake user object, exactly as if a real API call had succeeded. We render user profile, and because the fetch is asynchronous, we use find by text instead of get by text. Find by queries automatically wait for the element to appear, which is exactly what you need when you are waiting on a promise to resolve. A quick related point worth mentioning: if an interviewer pushes further for more complex scenarios, many teams also reach for a tool called MSW, Mock Service Worker, which intercepts actual network request at a lower level, so your component code doesn't even need to know it's talking to a mock. But just don't mock, like we have shown here, is the simplest and most common starting point. So next question, what is snapshot testing and what are its pitfalls? So this is the last testing question in this video. What is a snapshot testing and why do some experienced engineers push back on relying on it too heavily? So a snapshot test renders a component and saves a serialized representation of its output to a file on screen. To match snapshot doesn't exactly does the same thing the first time this test runs. Just creates a .snap file capturing the rendered output every time. After that, it compares the current render against the saved snapshot and fails the test if anything differs. So this sounds great in theory, instant regression detection for any UI change, but in practice it has a real pitfall, and this is worth mentioning practically in an interview. Developers often see a failing snapshot test, doesn't carefully review what actually changed, and just run the update command to accept the new snapshot without real scrutiny. At that point, the test is not actually verifying correct behavior anymore. It is just rubber stamping whatever the code currently outputs. So because of this, snapshot test work best for small stable pieces of UI. A simple button, an icon, where changes should be genuine and are less useful for a large frequently changing components where reviewing against snapshot dip by eye isn't practical. So let's move to slide next. So situational question now, the kind where the interviewer wants to see your actual debugging process, not just a definition. First one, a search input lags on every keystroke. How do you approach fixing it? So I will start by not guessing. Open the React DevTools profiler, record while typing, and see exactly what's re-rendering on every keystroke and why. Often you will find the input state lives too high up the tree, so every keystroke re-renders a large parent component and everything underneath it. The fix is usually to isolate this state, move it down into the smallest component that actually needs it. So a keystroke only re-renders the input itself, not siblings that have nothing to do with typing. From there, wrap any expensive sibling components in React.memo so they don't re-render just because the parent did. And if the lag is coming from something the input triggers, like filtering a large list or firing an API call on every character. That's exactly the debounce pattern we covered earlier. Wait until the user pauses typing before doing that expensive work. On screen are the three steps in order: profile first, isolate state, then memorize and debounce. Leading with profile first is the detail that shows real debugging experience rather than jumping straight to guessing at a fix. So, user reports a memory leak after navigating between pages. How do you approach it? So another realistic situation question, your app is slowing down and eventually crashing the tab after user navigate around it for a while. How would you actually go about finding a memory leak? So first I will confirm and reproduce it properly rather than just trusting a bug report. Open the browser DevTools memory tab, take a heap snapshot, navigate around the app a bunch of times, take another snapshot and compare. If memory keeps climbing and never comes back down after components unmount, that confirms the real leak. From there, the most common React specific cause is a use effect that set up something, a subscription, An event listener, a timer with set interval, but that doesn't return a cleanup function to tear it down. Every time that component mounts and unmounts, you are adding another listener that never gets removed, and each one might be holding a reference to state that should have been garbage collected. The subtler cause worth mentioning to really stand out stale clauses. If a callback captures in an effect gets held onto by something outside React control, like a global event bus, it can keep an entire or render state alive in memory even long after that component is gone. On screen are the three steps reproduce with heap snapshot, audit your effect cleanup function, and specifically was the stale closer holding onto old state. Question number 28. Um, you need to async state across multiple browser tabs. How would you do it? So here's the scenario question that's a bit more unusual but does come up. How would you keep stale like a shopping cart in sync across multiple open browsers tabs? The most common dependency free approach is local storage combined with the browser's built in storage event. Here's the key detail people often don't know, which when one tab writes to local storage, that tab itself does not receive a storage event, but every other open tab on the same origin does. On screen, we write our card to local storage whenever it changes in the current tab. Every other tab has a listener on window for the storage event. Check that the changed key is caught and updates it on local state from the new value, keeping all tabs in sync automatically. If you want something more powerful than plain local storage, for instance, real time messaging between tabs rather than just detecting a value change, the broadcast channel API is the modern alternative, letting tabs send actual messages to each other directly. The interview signal here is knowing that this is a browser level problem, not really a React specific one. React just re-renders based on whatever state you feed it from that storage event. So let's move to 29th. So how do you approach reviewing a teammate's React pull request? So let's move into behavioral question now. So these are about how you actually work, not just what you know. First, we walk through how you review a teammate's full PR. Uh, so you can say I always start by understanding the intent before reading any code. What problem is the PR actually solving and what was the agreed approach? Reviewing code without that context means you end up commenting on style instead of substance. Then I look at correctness first. Does the logic actually handle the edge cases? Are hooks used correctly? And there are hooks rule. Are there any hooks rule violation? Is there a missing effect cleanup? Is error handling in place? Only after that do style and formatting even comes into it. And honestly, a lot of that should be handled automatically by a linter and prettier, not by a human reverse time. And when I do leave the comments, I try to make them actionable and kind, explain why something's a problem, not just that it is suggesting a concrete fix, or ask a genuine question if I am not sure, and clearly separate blocking issues from optional nice to leave, so the other isn't left guessing what actually need to change before merging. So tell me, uh, next question. So tell me about a time you significantly improved a slow React application. So this is the last question for this video, and it's one of the most common behavioral prompts you will get. Tell me about a time you improved a slow React application. The best way to structure an answer like this in the star method: situation, task, action, result. And it's worth actually knowing that framework by name going into an interview. Situation and task. So briefly set up what was actually slow and what the goal was. For example, a dashboard page was taking several seconds to become interactive, and the target was to get it under specific measurable threshold. Action: this is where you go specific. You profiled it with the React DevTools profiler. You found the actual root cause, whether that was an oversized bundle, unnecessary renders, or an unoptimized list, and then the concrete fix you applied. Maybe that was code splitting a heavy route, memoizing an expensive component, or virtualizing a long list using the exact techniques we have covered throughout this video. Result: always end with a real, ideally measurable outcome. Load time dropped from this to flat, so a specific metric improved by a specific percentage. And a strongest closing touch: mention what you have do differently next time, or what you learned, since that shows genuine reflection, not just a rehearsed success story. On screen are the three part of that structure. Having a real example ready, told this way, is one of the highest leverage thing you can prepare before any React interview. So this is the last slide of this video. So, and let's wrap for video 2. We went from state management, Redux, context, and Zustand through performance optimization, rendering strategies like SSR and SSG, testing basics with Jest and React testing library, and closed out with situational and behavioral questions. If this helped you, drop a like, subscribe if you haven't done already, and let me know in the comments which topics you want cover next. So in next video I'm going to I will go deeper in React in internal and system design, building a library, accessibility, TypeScript, React, etc. So thank you for watching. See you in next video.